In this video, we will be creating an engineering drawing for a part model in Solid Edge. Start by opening a new ANSI metric draft template. Click on View Wizard command and open the coupling arm part file. Notice how Solid Edge gives us a live preview before we place the view, and as we drag the cursor, we continue to get live previews now of the projections. Let's create a top view and an isometric view. Let's create an auxiliary view to best dimension the cutout in the model. This is as easy as touching the model to where we want it to align. We don't need to see the entire view, so to crop, it's as easy as dragging the frame to suit. The maintain alignment can be turned off in order to place the view in desired location. Another type of view that's popular is a detailed view to magnify small details in a design. We can roll the mouse wheel to increase or decrease the scale of the view or change it from the command bar. Let's make this 5:1. And if the detail circle location changes, the detail view will update, ensuring the correct information is displayed at all times. The next thing we want to add is some center marks. It's as easy as selecting where you want to place them. Here we may want to have these center marks aligned with the edge of the part. The center mark command makes it quick and easy to do that. Also, we want to add some center lines to areas that have a side view of holes. Again, it's quick and easy to just select the two lines that make up the holes. Since all the dimensions were added in the 3D model, what we can do is retrieve those dimensions from the model, and Solid Edge will pull all those dimensions to this view. Notice even the tolerance detail comes through too. Cleanup is as simple as dragging things around on the screen. You can also add dimensions yourself using Smart Dimensions. By selecting items in the view, notice how easy it is to place the types of dimensions needed. Some people like to trim extension lines back to the theoretical sharp corner. That's as easy as selecting these nodes and dragging them back to the outer edge. What I used there is what we call the Smart Dimension command. The reason we call it Smart Dimension is because I'm picking on a radial edge, I get a radial value. If I click on a circle, I get a diameter. If I click on two circles, I get this vertical dimension, or if I hold down the Shift key, I get the shortest distance between them. One tool to do all these different types of dimensions. If I click on two lines and select the A on the keyboard, I get an angular dimension. So I don't have to learn a lot of different dimensioning tools, I can just use the one command. For any prefixes, suffixes, or suffixes even, that's easy. Here let's type TYP, as this is typical radius on this part. I'm a little lazy because I know that 20mm is also a typical dimension, so I don't want to type that again. We can copy that attribute from one dimension to another. Let's move that dimension to the outside. Notice how the dimensions are staying lined up with one another. Here, if we want the arrows of this dimension to be on the outside, we can simply click and drag. Next, let's create a feature callout. If we click on a feature, such as one of these holes, you can see that it's extracting that information directly from the 3D model. Let's finish out this auxiliary view. We need the auxiliary view to describe the depth of the slot. Using the Smart Dimension, we can add the depth dimension. Remember, this enlarged view is 5 times the size. So, if we dimension this radius, is it going to be 5 times too big? No. Solid Edge will extract the actual dimension directly from the model. Now, Solid Edge can of course create your usual section views, but for a final view, let's create a broken out section. To create this, let's create a circle here in the front view. Then tell Solid Edge how deep we want to cut on another view. And then we can place the result in any other view. Easy, and notice how Solid Edge automatically places the correct hatch. In this video, we learned how to create a drawing of the part model. We added a variety of views to clearly communicate our design, retrieved dimensions directly from the model, and finally added further dimensions and annotations.